I'm Ben Brooks, Senior Software Engineer working on the Sync Gateway product for Couchbase Mobile, and I'm here with Priya.
Hey all, I'm Priya Rajgopal, Director of Product Management here at Couchbase, responsible for our mobile and edge computing solutions. And today we're going to talk about what's new in Sync Gateway configuration and administration. At Connect earlier today, we announced the 3.0 beta release of our Couchbase Lite and Sync Gateway products. This is a major release introducing significant enhancements on Couchbase Lite side, and on the Sync Gateway side, we've introduced core architectural enhancements in the areas of security and manageability. In this session, we'll dig a little deeper into one of the release defining features on the Sync Gateway, namely centralized persistent configuration support. So for context, I'll give a quick overview of the Couchbase platform. I won't be going into any details in this presentation. So first, you've got Couchbase Server, our flagship, highly scalable, distributed NoSQL data platform, got an integrated cache, number of services, built-in services like indexing, query, full text search, eventing, analytics, etc. Optionally, you can build web services applications that interact with Couchbase Server using one of our many SDK clients. Then on the far end of the spectrum, you've got Couchbase Lite, which is our NoSQL document JSON store for, it's an embedded database for mobile, desktop, and embedded platforms. And sitting between our Couchbase Lite clients and Couchbase Server is our synchronization gateway, or the Sync Gateway. As the name indicates, its primary responsibility is data synchronization. It enforces access control, authentication, and authorization. Now, if you're working with Sync Gateway, this should be quite familiar to you. Currently, in order to configure the Sync Gateway, the configuration is provided via a JSON formatted configuration file. So you provide that to the Sync Gateway on launch. Now, this configuration file is monolithic, which really means that the entire configuration is provided in this giant configuration file that includes Bootstrap information, database information, the access controls, authentication mechanisms, users, etc. Now, since the database is part of that configuration, it is node scoped. So what it means that if you have a cluster of, say, 10 nodes and they have identical database configuration, you have to independently configure every node in that cluster with that database configuration. Again, we mentioned that the Sync Gateway is configured using a static configuration file, which means any ad hoc changes that you may have to make to the Sync Gateway configuration after startup, you have to log into the Sync Gateway and you have to make changes to that file. You have to restart that file. You have to repeat that process for all the other nodes in that cluster. Now, if you're wondering, hey, wait a minute, there is a REST endpoint. There is a database configuration endpoint. Can't we use that? Well, if you've tried that, you probably realize that changes that you make through that database configuration endpoint don't survive restarts. So even if you make those changes, that affects the runtime behavior, but subsequently when you restart the Sync Gateway, all those changes are lost because it's going to pick up that configuration from the static configuration file. So what are we doing about this in 3.0? So in 3.0, we are moving away from the monolithic approach to a more modular approach for configuring the Sync Gateway. So now you can independently configure various aspects of the Sync Gateway. So like the Bootstrap can be configured independently of the database and the access control policies and so on. They're really it's intuitive, right? There are many benefits to doing so because maintaining a monolithic file, especially in a very complex environment, is difficult, it's tedious. So as an example, right, a very simple example, consider the case where you have a configuration file. It hosts the database definitions, number of database definitions, say one for each tenant or environment. You know, one pointing to a dev cluster, dev bucket, one pointing to a test bucket, and so on. And you want to make changes to one of the database configurations. Well, to do that, you have to edit that configuration file and make those edits to that database configuration and then restart the Sync Gateway. Well, because that configuration file holds the database configuration for all the tenants, all the environments are going to be affected. We're moving from the node scope because database approach to making the database configuration cluster aware. So this means you have the ability to centrally update the database configuration. So changes that you make to one node in the cluster are automatically applied to other nodes in the cluster, or you can scope that to a subset of nodes. We'll talk more about that in following slides. Now, how do we do that? In order to do that, we are moving that database configuration away out of that JSON configuration file. So all database administration is now done through the admin REST endpoint. So you no longer have to log into the sync gateway in order to make changes. You just make that change through the REST endpoint, and the system takes care of automatically applying that to all the other nodes in the cluster. And if you're wondering, hey, well, Priya, in the last slide, you just said that those changes that are made through that database config file are not persisted. Well, the good news is now we have fixed that. So all changes, ad hoc changes that are made through the database REST endpoint are persisted, and they will survive restarts. So all these changes, as we learn later, are persisted in the backend bucket on Couchbase server. So let's walk through a typical workflow that a user would go through in order to set up the sync gateway. You start off with bootstrapping the sync gateway. This is the process where you launch the sync gateway, attach it to a Couchbase server cluster. Next, you configure one or more databases. Now, this includes things like giving the database endpoint name, the backing bucket name, some configuring optional parameters like cache setup, whether you want deltas enabled or not, the authentication mechanism to use and such. Then the next logical step is you would configure read-write access policies, and this you do through a JavaScript sync function. And finally, you add users to the system. Now, user management is technically not configuration. The authentication mechanism is, whether you're doing custom auth or OIDC, that's part of the configuration. But users can also be registered automatically through mechanisms like OIDC, as is the case today, but you would want to configure the authentication mechanisms. So let's, with that background in mind, let's walk through the various stages and how that applies in the context of the new persistent configuration support. Starting with Bootstrap. How do you bootstrap a sync gateway? You still need to bootstrap the sync gateway with providing it with a JSON configuration file. But don't worry, this Bootstrap configuration file is very minimal. This example that you see is the bare minimal information that you need to provide. In fact, even the logging setup that is specified there is optional. If you don't need console logging and you're okay logging to the default location, you don't even need to specify the logging option. So only the Bootstrap object needs to be specified. In that minimally, you have to specify the server that the sync gateway needs to connect to and the credentials with which the sync gateway will authenticate itself against the server. Notice the highlighted group ID parameter. This is an optional parameter, so you don't have to provide one. If one is not provided, it defaults to a default group. Now, the use of this group ID parameter is going to get clearer when I walk through some examples in subsequent slides, but at this point, it suffices to say that this group ID identifies the scope of the database configuration. So it defines the set of sync gateway nodes to which the configuration will apply. Okay, so now you have Bootstrap, the sync gateway. It's connected to the server. Now let's talk about how the database is configured. As I mentioned earlier, all database configuration is done through the REST endpoint. So in this example, let's assume that the group ID is not defined. So all the sync gateway nodes belong to the same default group. So you hit one sync gateway node, passing it the database configuration. That configuration gets persisted in the Couchbase server bucket, and it's picked up by other nodes in this cluster. In this example, by sync gateway node. Now, if you were to add a third node to the cluster, Sync Gateway 3, and let's assume it belongs to the same default group, that node will automatically pick up that database configuration. So you don't need to individually configure every node in the cluster through the REST endpoint. Now, this REST endpoint is secure. We'll talk more about it later. So you could actually do that administration remote over the internet. So that REST access could happen through the load balancer. For simplicity, in this example, I'm just showing that happening directly through a backend application. So in the previous example, we saw how you can configure a homogeneous cluster, right? Where all the databases in all the sync gateways in the cluster have the same database configuration. That's probably a majority of sync gateway deployments. But then there might be cases where you may have to segregate the workload. So you may not have all the nodes configured the same way. So consider this example. You've got 3 Sync Gateway nodes. You've got 2 of those Sync Gateway nodes, Sync Gateway 1 and Sync Gateway 2. They are fronted by a load balancer and they participate in client replication. And then you've got a Sync Gateway 3. This node doesn't participate in client-side replication, and it's exclusively reserved for handling import processing. If you're not familiar with what import processing is, it's at a high level, it's the process by which the Sync Gateway listens to mutations coming in from the Couchbase server bucket, and it decorates it with sync data and makes it sort of sync ready and ready for client replications. Again, many reasons why you might want to segregate your workload this way and size your cluster this particular way. So in order to accomplish something like this, Sync Gateway node and Sync Gateway 2, you set it up to belong to a group ID of sync, okay? Sync Gateway 3, because you want it in a separate group, set that up to belong to a group ID named import. This has to be specified as part of the Bootstrap config that we saw earlier. Now we'll configure Sync Gateway 1 and Sync Gateway 2. You would do that through the REST endpoint. The database changes, the database that you create through the REST endpoint is persisted in the bucket. It's applied to Sync Gateway and Sync Gateway 2, which belong to the sync group. But you can see in this animation, it doesn't apply to Sync Gateway 3 because it belongs to a different group. So in order to configure the Sync Gateway 3, again, you use the REST endpoint provided with the database configuration. And once again, that configuration just applies to Sync Gateway 3, and it's not propagated to the other nodes in the cluster. So from an end user standpoint, you really don't have to worry about any of this. You just have to give the group ID, and the Sync Gateway takes care of the rest. So following through the workflow, right, you've got the Bootstrap, you've done the database configuration. The next logical step is access control. This is who has read-write access to the documents. Now, this is specified through a JavaScript sync function, and that's associated with the database. Once again, you do it through the REST endpoint, and you have 2 options for doing that. So you can do that as part of the database configuration REST API. So the same API that you used for doing the basic database configuration, you can embed the sync function as part of that configuration, and that's shown in the highlighted text. Alternatively, if you don't want to embed that as part of the database configuration and you want to exclusively configure the sync function, you can do that through a new REST endpoint. It's part of the database configuration, but it's a sync endpoint as shown in the highlighted text. You provide the content type, in this case is JavaScript, and you provide it with the JavaScript function. It's very, very straightforward. The same applies for configuring import filters. Configuring import filters, it's optional. You know, if you want to filter the subset of data that is imported by the Sync Gateway, you define the import filters. Once again, you have to configure it through the REST endpoint. You have 2 options for doing that. You do that as part of the database configuration, as shown in the highlighted text. Otherwise, you have the option of using an import filter endpoint, specifying the content type to be JavaScript, and you provide the import filter JavaScript function. Now, the final step is the creation of users and roles. It's about user management. Now, in 2x a version of Sync Gateway, or in the current version of Sync Gateway, you had the option of statically configuring users, and you would specify that as part of your JSON configuration file. You also had this guest user, but as I mentioned, technically user creation does not belong, it's not part of the configuration. It is a critical aspect of the Sync Gateway setup workflow and deployment workflow, but it doesn't really belong to, as part of the Sync Gateway configuration. So what are we doing about it? We are removing configuration of users, static users, from the configuration file. So how do we configure users? You will configure users through the REST endpoint that is available today. In fact, majority of production deployments will use this REST endpoint. It's really just in dev and test as an easy way to do demos. One would embed the static users as part of the configuration file, but that's never really the case in a real world or production deployment. Now, this is the same endpoint. Nothing changes from what exists today. And of course, you also continue to have the option of auto-registering users with the Sync Gateway, for instance, as part of the OIDC workflow. Now, what about guest users? Now, guest users is sort of slightly different than regular users, regular Sync Gateway users. When you enable guest user access, you're effectively enabling anonymous authentication. So it's really a guest mode that you are enabling. So that rightfully belongs to a database configuration. So you would specify that as part of your database configuration. Okay. So again, the distinction needs to be understood that, guest user is really a guest mode, and the rest of them are actually Sync Gateway users or users of the Sync Gateway. So if you are an existing Sync Gateway user, what do you have to consider when you're upgrading your cluster to 3.0? Note that this is a persistent, centralized persistent configuration is enabled by default. We have an auto migration capability available. So you bring in your legacy configuration file. We'll take care of splitting it up, creating the Bootstrap configuration, creating the database config, persisting it in the database, etc. Now, of course, this works if you have all the nodes have the same configuration. But if you want to auto migrate a cluster where you have some nodes that have a different database configuration, all you have to do is include that group ID parameter in your existing configuration, and we'll take care of the rest. Note that this is a one-way operation. So once we have migrated your cluster from the old way of doing things or legacy way of doing things to the new persistent format, you can't revert back. There is an opt-out option available. Despite all that we have talked about today, if you are still not convinced that you have to, you're ready to migrate right away, you have an option of disabling that and continuing to do the old way of doing things. But however, we would recommend that you adopt the new way, which is our recommended way going forward. This option is really available as a convenience. For instance, you want to pick up all the other features on Sync Gateway 3.0, but you are not quite ready to adopt the persistent configuration option. Now that all the database configuration is done through the REST endpoint, it's imperative that it is secure. So starting 3.0, all admin API accesses must be authenticated. Now, the user that is used for admin access is configured on the server, on Couchbase server, as an RBAC user. It's done the usual way, the way you configure other RBAC users on the Sync Gateway, on Couchbase server. The table here lists the RBAC roles and the privileges. There are certain cluster level roles for enforcing cluster level accesses, like fetching Sync Gateway configuration, running SG-collect info for collecting for support log processing and such. But the majority of the operations are at the database level. And for that, if you're on the latest version of the server or a more recent version of the server, you should be using the Sync Gateway role. Now, the roles that are currently supported are quite coarse-grained, but in a future release of Couchbase server, we will be introducing support for finer-grained roles. Once again, if you're upgrading from Sync Gateway, the existing Sync Gateway cluster to 3.0, note that this is a breaking change because authentication on the admin API is enabled or required by default. So if you are using the admin API for any reason and there is no, there isn't any authentication support today. Now, exclusively for dev and test environments, we have an opt-out option. You can opt out of authenticating the admin REST endpoint, but we would strongly recommend that for production deployments, you go with the default, which is really the best practice. Here's a quick summary of the admin REST endpoint. We discussed most of the APIs earlier. We have APIs to retrieve the Sync Gateway configuration. This is the Bootstrap config, the node config that you launch the Sync Gateway with, but we have options to include or exclude the runtime configuration. So what's the runtime configuration on the Sync Gateway? You can retrieve that along with the default values that are set for the various parameters that are not specified. You notice that we have a put on the Sync Gateway configuration. The only Bootstrap or node level configuration that can be updated after startup is logging at this point. So for some reason, for debugging purposes, if you want to increase the log level, you can do that through the REST endpoint. That change is not persisted. As I mentioned, that is part of the static JSON Bootstrap file. So subsequently, when you restart, it's going to pick up the log configuration that is specified as part of that configuration file. We talked about the database configuration APIs. Just note that there are a lot of query parameters that are available that allow you to filter or exclude details around the sync function, import filter function, and so on. Database management, you have the option of retrieving the details of the database. You can also delete the database. We've talked about the APIs for configuring access control through the sync endpoint, import filter through the import filter endpoint. Note that all put operations support optimistic concurrency, and you can specify that using the etag if match HTTP headers. No changes to user management through the REST endpoint. This is the API that exists today. The only distinction, as I mentioned, is how you specify the guest user access. It's specified as part of the database configuration through the REST endpoint. Replications refer to intersync gateway replications. This was introduced in 2.8, this endpoint. There are no changes to that endpoint. You will continue to configure your intersync gateway replications through this endpoint. Just a quick note that SG replicate is removed in 3.0. So we would encourage you to migrate to the new intersync gateway replication protocol. Now, with that background, over to Ben for a demo.
Thanks, Priya. So today I'll be demonstrating the new persistent config feature of Sync Gateway 3.0, and we'll be creating and updating database configurations using the new secure remote administration feature. So I've already got a Couchbase server running with the beer sample bucket loaded and 2 RBAC users configured already. The first RBAC user is a Sync Gateway app user, which is the user that Sync Gateway uses to connect to Couchbase server. The second user is a Sync Gateway admin user. This is the user that I'm going to make the REST API requests through. And so that's going to authenticate me and allow me to create and update databases. So my demo uses Docker Compose. I'm going to start up multiple Sync Gateway nodes locally in containers, and they're all fronted by an Nginx load balancer. So it's a pretty minimal configuration. The Nginx load balancer is configured to listen on the standard Sync Gateway ports, and it's just going to forward those requests to one of the Sync Gateway containers that are running. The Sync Gateway containers all share the same config file. And so here you can see the minimal Bootstrap config that we've got for the Sync Gateway containers. They contain the address for Couchbase server, and they contain the Sync Gateway app user that I mentioned before. Other than that, there's just some logging configuration, just so we can see what's going on. And apart from that, that's it. Note there are no database configs here. We'll create those through the REST API. So with that, I'm going to use Docker Compose to start up 3 Sync Gateway containers and the load balancer. And we're going to go and look at the logs as well while they're running. So here you can see that we've got a Sync Gateway 1 node, a Sync Gateway 3 node, and Sync Gateway 2 node. They've all started up, as well as the load balancer. And in the logs, you can see that there are no database configurations for the default group. This basically means that the Couchbase server was scanned and all of the buckets, and we found no database configurations because we've not created any yet. But note that all the Sync Gateway nodes have started up their REST APIs, so they're ready to serve requests through the admin API. We can go and send a request to the config endpoint to view the runtime config. And we can see that the load balancer has received this one request, and it's just routed it to one of the nodes. If we continue sending requests, we can see that the requests are round robined to any one of those containers. So we can see that it's hit Sync Gateway 2 and Sync Gateway 3. So here, this is the running configuration. It's got the Bootstrap config that we provided in the config file. But down the bottom, we can see that there are actually no databases running at the minute. In this request, we can create a new database and point it to the bucket that's already populated in Couchbase server. So this request will go and hit one of the Sync Gateway nodes. And it doesn't matter which one takes the request, it can go and create the database. It will populate the config file in Couchbase server. And once that's done and initialized, this config file will actually be distributed to all of the other nodes in the cluster. So if we go back and view the node configuration, this can be run on any node. As we can see, it's load balanced still through any of the nodes. And then if we take a look at the databases down the bottom, we can actually see that this beers database has been loaded up with the beer sample bucket. This is now on all 3 nodes. And we only had to create the database configuration on one of them. The nice thing about this is that we can actually scale up Sync Gateway quite easily now. So I can use the scale command to start up 10 Sync Gateway nodes. They'll all be sat behind the load balancer, and they'll all read the same configuration file in the cluster. And so just like that, we've got 10 Sync Gateway nodes all sharing the same database config without actually manually distributing that config to 10 different places like we used to. If we wanted to update the database, let's say our cache was undersized. Let's say we want to increase this rev cache size on all of the databases. What we can do is we can send an update database request and just do an upsert on the config. This will be applied to one node first, and then once it's loaded, it will be redistributed to all of the other nodes in the cluster. You can see here all the other nodes are picking up that change now. And then if we go and look at the node config again and go down to the database, we can see the rev cache size has been increased across all 10 nodes instantly. So now let's say we want to add a Sync Gateway import node to this. At the minute, this configuration does not import documents. Let's say we want to isolate that to a single node that's not serving client requests. This is what we can use the config group ID for. So if I go back to our Docker Compose file, you can see I've got another node here for SG import. This has a completely separate config file, but the only difference in here is this group ID. Everything else is exactly the same. So again, I can use the scale command to actually start up one Sync Gateway node. And again, you can see that the import node has found no databases because we've not created a database in the import group. So just like before, we can create a new database on the import node for be a sample, just like before, except this time we've got import docs true. And now you can see the import node has actually loaded up the database and it's going through all of the documents in the bucket and running import on them all. Note that none of the other Sync Gateway nodes in the cluster are performing import work. This is just completely isolated to this one node. And then just like before, we can actually apply config to this import node separately from all the other Sync Gateways in the cluster. So maybe we want to tune down our cache sizes to save on some memory. We can just send this request to the import node specifically, and it's only that database that actually gets this config. We can go and observe the import config at the minute and take a look at the cache sizes. And we can see that we've tuned down all the cache sizes. If we go to the first set of Sync Gateway nodes that were actually serving client requests, the ones that would need the caches, they're still the same. So we've basically completely segregated the workload. And you can just as easily spin up 5 import nodes if you like, if you have more requirement for extra import, or you can scale up the client nodes independently as well. But you can see how easy it is to actually manage the database configurations through this. The second demo that I'll do is demonstrating the automatic upgrade feature. So let's say you have a 2.8 Sync Gateway config file. We've seen before that these config files are actually really big and contain everything, especially all of the database configurations. So in this case, we've got a config file that actually has 3 databases in it. And you can see that it's pretty large. It's 170 lines of config. And this would actually have to be distributed on all 10 containers or all 10 nodes. However, if we use this old config file on 3.0, it will automatically upgrade this, turn it into a minimal Bootstrap, and distribute all 3 database configurations to the cluster to be loaded up. So I can demonstrate that now. I'll just shoot down everything that I've got. So the legacy container is just going to mount this entire directory for the SG legacy config. And the way the upgrade is going to work is it's going to read this old config file. It's going to do the upgrade, like I said, but it's going to back up this config file first if you want to keep it for any reason. And then after the upgrade's been applied and the 3 databases have been successfully written, this config file will actually be overwritten with a Bootstrap config. So we can take a look at that in a second. So this is going to start up one Sync Gateway legacy node. And because I'm sharing the same Docker Compose file, I'm just going to set the other containers to 0. So Sync Gateway is kind of already started up now. I can actually view the node config that's running. Note that we've got a legacy group ID in here to keep it separate from the previous demo. And you can see down here, we've got all 3 databases running as well. If I go back to the legacy config file that we had, you can see it's been replaced by a minimal Bootstrap config. So it contains the legacy config group ID, contains the credentials required to connect to Couchbase server, but note it contains no database information in here. The backup file, like I said, has been written there for convenience. If you want to, revert back for whatever reason or have it as a reference, it's there. But the next time Sync Gateway is going to start up, it's going to just read this minimal Bootstrap config and load the databases out of the bucket. So we can actually kind of restart this and it will start up instantly. So as you can see, the new configuration is actually a lot easier, especially with large numbers of nodes in a cluster. So that's the demo. Thanks.
Thanks for that, Ben. That was fantastic. Hopefully, managed to convince our users that it's incredibly easy to now configure and administer the Sync Gateway cluster. The auto migration capability takes care of a lot of the heavy lifting and hard work if you are starting with an existing configuration. Leaving you with some helpful resources where you can find more details on the new configuration, the REST endpoint, and how you can download the Sync Gateway and get started with this. Finally, again, I'm Priya Rajagopal with the product management team and joined by Ben Brooks from the engineering team, and happy to answer any questions. Thank you.